All right. Well, what we're going to do today, guys, is we have our test that's going to open up today at noon, and then you have until tomorrow night to finish it. I believe it's 18 questions, so it shouldn't be too long, too bad. You don't have to like sit down in one sitting and do the whole test. You can like look at a couple problems, do some easy ones, and then come back to it later if you need more time. This is the only thing that's required for today, so you don't actually have to take the test today if you don't want to. But the nice thing is if it's open soon enough, you can look at it and go through some stuff. You got a long time to do it. So hopefully it shouldn't be too bad for you guys. There's a couple maybe more difficult problems that were on the review more than on the test. And it is multiple choice, so you can just kind of, multiple guess if you really need to. So this is what we're going to do today. I have, unless you guys have any questions, I actually have, it would have been our quiz that we took for the chapter, which is on kind of, I think the harder part of this section was actually the first half of the chapter. Normally it's the second half, but this time I think it was the first half. And so we'll go through those questions, and then if you have anything else, we can talk about that, okay? Okay. All right. So let's go like this. All right. So let's see. I think I can. This is a PDF, so I think I can open this in Canvas real quick. So let's see. Guess I should have had this going. How have all your other classes been going, guys? Okay. Not good. Let's see. Just trying to think. I felt like there was going to be something I was going to say to you guys, but I can't remember what it was off the top of my head now. I don't remember. Oh, that's what I was going to say. Just as a heads up for you guys, so what we're doing next, like the chapter after this one, I suppose I could tell you at the end, but what we're doing in the chapter after this one is actually going to be, if you look up here, and maybe you notice this on everything, it always said Algebra 2, Chapter 13. And so, but I always called everything Chapter 3. And the reason that is because in our probability book, it was Chapter 3. But it's the same stuff as in our Algebra 2, Chapter 13 chapter, which is shorter. And so what we're going to do is we're actually going to, now after this chapter, we're going to go do the chapter from our probability book. So it should be very similar stuff. It's just going to be, the sections are going to be a little bit longer, so they'll take more time. And hopefully it'll be a little bit easier because you'll have some good background knowledge, because this I think was a really good kind of shallow water test of it. And then we'll look at the rest later, okay? So hopefully it'll be easy. Okay, so let's go over some of these answers, and then we will, if you have any more questions, we can go over them. So number one, it says the service club is going to build a house for a needy family or serve dinner at a homeless shelter over spring break or Memorial Day weekend. Draw a tree diagram to represent the sample space. Now, obviously, you're not going to have to draw a tree diagram on your test, but this is how we do it, okay? So we have two choices, right? We can either, it's either going to be build a house, so we'll write house, or it's going to serve dinner. So right here, I'm going to say dinner, right? Okay, so those are our two choices to start, right? Then it says we can do it over spring break or Memorial Day weekend. So what we're going to say is I can either build a house over spring break or Memorial Day, okay? And the same is true for our dinner, right? And so we would say spring break or Memorial Day. Okay, so what that means is that I can either build my house during spring break or during Memorial Day. So I have two choices there, or spring break and Memorial Day. So how many total outcomes do I have here in the sample space? Well, there's 1, 2, 3, 4 outcomes that we can have. So 4 outcomes. okay? And so that is the type of problem that we might actually have on our test. How many outcomes are here? So what we do is we say, okay, there's 2 right here, 2 options, and each one has 2 more options. So you take 2 times 2, and you get 4 outcomes, okay? Okay, all right, next one, number 2. The art club is randomly choosing a president and a vice president from its 15 members. What is the probability that Matt and Lisa are chosen? Okay, so what that means is the important thing of this, and I said it in the video, we have 2 options, okay? There's either combinations, so I'll write this out. There's either combinations or there's permutations, right?
Buddy, come here.
Okay, those are our two different things that we can have, right? Now, combinations are when order doesn't matter. And a permutation, right? A permutation is when order does matter. Okay, now, if we look at this problem right here, number 2, we notice it says they're choosing vice president and a president, right? So we're choosing 2 different things, and it says that they are chosen. It doesn't say that Matt is the president and Lisa is the vice president. That would be a permutation. So what we're looking for is a combination. So all we have to do is we just go to Desmos, okay? And remember, in our scientific calculator, we go to functions, and combination is the big one with a C, right? So we're doing a combination, and the first number is how many total we have. So they said there's 15 members, and we're choosing 2 of them. So you'll notice this right here, 105. 105 is what we're looking for, right? And so the probability of that happening is 1, because those 2 being picked is 1 choice out of 105, okay? All right. Number 3, it says a city bus stops at the city park every 15 minutes. What is the probability that someone arriving at a random time would have to wait more than 5 minutes? Okay, so this is one of those geometric probability problems. Okay, and so it says like this: if the whole wait time right here, oops, I drew over that. If the whole wait time is 15 minutes, right? 15 minutes. Okay, and we want to know if someone has to wait more than 15 minutes. Well, or excuse me, more than 5 minutes. So if we break this up into thirds, right? This is 5 minutes, right? This is 5 minutes, and this is 5 minutes. So if they have to wait more than 5 minutes, that would be this one, so 5, and then 10 minutes here, right? They could wait more than that. And so the probability of that happening would be 2 out of 3, or you could have said it's 10 out of 15. Oops, 10 out of 15. Okay, any questions about that? I muted you guys, not whatever, but if you guys have any questions, let me know about that. Does that make sense though? If it's more than 5, that would be 10 out of 15, would be 2/3. Okay, if they wanted it as a percent, we would say it's 66%. Remember, if they wanted it as a decimal, it would be 0.66. And if you ever want to change from percent to decimal, remember, you just take percent divided by 100 or decimal times 100 to find a percent, okay? All right, next one. It says, find the probability of the pointer of the spinner landing on purple. Well, you'll see purple right here is 100 degrees, right? So we're going to call this 100 degrees. Out of the whole circle, which we don't even have to add them up. We know that a whole circle is 360, right? So 100 degrees out of 360 degrees, that probably isn't an answer that you'll see on your test as an option. So what we do is we go to our calculator, and we do 100 divided by 360, and we get the reduced fraction of 5 over 18. So this is really 5 out of 18. Okay. All right. Check real quick, make sure nobody's still waiting to get in. Okay. All right. Number 5. What is the probability that a phone number generated with digits 0, 1, 2, 2, 3, 3, 5 is that specific number right there? Okay, if the 2 digits cannot be a 0 or a 1, right? So what that means is if it can't be a 0 or 1, automatically it gets rid of those 2 right there. So now we're left with 1, 2, 3, 4, 5 choices. Okay. So the first number has 5 different places it could be. Then the second number has 4. The third has 3, 2, and then 1. So we call that a factorial. So it'd be 5 factorial divided by, and now, okay, so just to recap on how I got 5. I just counted what numbers were left, because all phone numbers, well, not all, but the last 7 digits of the phone number are these 7 numbers right here. And it says, since the first number cannot be a 0 or 1, we're only looking at these 5, right? So it's going to be 5 factorial. And then we're going to divide it by all the repeat factorials. So that I have 2 2's, so I'd say divided by 2 factorial. And then 3 3's, so, or 2 3's, so it'd be 2 factorial. And then the 5, I don't have to write 1 factorial. So what I'm going to do here is I'm just going to solve this out. And you could figure this out the long way. Otherwise, again, your calculator will do it real easy. So what we do is we say 5 factorial. And you'll notice the exclamation point isn't on here. You're going to have to just type that on your calculator. Divided by, and then we do 2 factorial times 2 factorial. And we see 30. So the chance of this happening would be 1 out of 30. Okay. All right. Any questions on that one? You'll have to unmute yourself if you want to talk, but no questions. Okie dokie. All right. Next one. These ones are going to be a little bit trickier. So hopefully I can help you out with the probability ones where they're like circles. The important things you have to remember are, remember, area of a circle is pi, and then times radius squared. Okay, that's important to know. Then I think you know how to find area of a rectangle or square, but remember it's just length times width, right? And I think that's pretty much all you're going to have to know. I don't think you have to know area of any other polygons or anything like that. Okay, so probability of a point chosen in a shaded area. So you'll notice that this little circle right here is just a small little circle. So what we're going to do is we're going to find the area of the shaded region, okay? So the area of the shaded region area is going to be pi, right? And then the radius of this, if the diameter is 4, you all could tell me that the radius is just going to be 2, right? And so when we multiply it out, I'm actually going to leave pi in my answer because it's going to cancel out when we find the area. So the area of the shaded region right there is pi, or 4 pi, excuse me. Now, the area of the whole thing, right? The area of the whole circle is going to be pi times, and if this guy is 2, 4, 6. So it's going to be the whole thing, right? All right. And so when we do that, we get 36 pi, right? And so then if we want to find the area of the whole thing, we just divide these two. And we can go here. We'll do 4 pi divided by 36 pi. And we end up getting 1/9. Or if they wanted a probability, they probably want 0.11, right? So either 11%, 0.11, or 1/9 would all be acceptable answers, right? And so the chance of that happening, remember we say if a chance is 50% or less, it's less likely, and then 50% or more is more likely, okay? Okay, any questions on that one? All right, sounds good. Number 7, okay? So the shaded region is the outside thing, right? And it's kind of deceiving, but if you were to take these two half circles, right, and put them all together, it would end up being just basically one circle, right? And you'll know that the diameter of that one circle, since the length of the whole thing right here is 6, you could also tell me that the diameter of this circle is, oh, check that out, that's pretty cool. All right, I guess I don't know what I'm doing. Okay, the diameter of that one is just going to be 6, right? Okay, so if you know that, okay, that's pretty cool, because now if you take that shaded region off, you could tell me the area of the rectangle right here is going to be 60, right? And all I did is I did 6 times 10 is 60. And then the area of the circle is just going to be pi times the radius. Well, if the diameter is 6, the radius is half of it, and that's going to be 3, right? It would be 3 squared, which is going to be 9 pi. So the area of the whole, I'll call it the blue figure right here, this is all in blue. The area of that blue thing is going to be 9 pi plus 60 units, right? 9 pi plus 60. And you could figure out what that is as a number by just going 9 pi plus 60 is going to be 88.27. 88.27. So that's the area of the whole blue figure. But our shaded region is just this right here, 9 pi. So what we do is we take 9 pi divided by 88.27, right? And then I just divide them, right? So 9 pi divided by 88.27, and I get this right here, that 32 number. So my probability would be 0.32, or as a percentage would be 32%. Okay. Number 8, it says find the number of possible outcomes for an election of class officers in which 2 candidates are for president, 3 for vice president, 4 for secretary, and 3 for treasurer. So this is one of those fundamental counting principle ones. We called it FCP, right? Fundamental counting principle, which again, big name, doesn't really matter. It just tells you that this, if there's 2 candidates for president, 3 for vice president, 4 for secretary, and 3 for treasurer, how many different outcomes? We just multiply. So 2 times 3 times 4 times 3, all right? And I just got to multiply that all together. So 2 times 3 times 4 times 3 is going to be 72. There's going to be 72 different outcomes we could have, okay? And again, we could draw a tree diagram or something like that, but that just sounds like a lot of work, so I wouldn't worry about doing that too much. All right, number 9, it says Sam is deciding between majoring in history or journalism at Eastern State or Central State, right? An organized list to represent the sample space. So again, okay, a list would be like this. So if he wants Eastern State, let's say E State right here, and then the other one is Central State, so C State. Okay, so here's our list, and then he can either pick, he would, you know, I'm gonna type this, this is ridiculous. Okay, he can either take history, or he can take journalism. And then over here at C-State, he could also pick history or journalism. So you'll see we have a nice list, and here is our 2 choices that he has for colleges, and he has 2 choices for majors. And so you could tell me then how many total outcomes there are, and you would just count over here. So 1, 2, 3, 4. There are 4 outcomes. Otherwise, you could have done 2 times 2, but that's fine. So 4 outcomes total. Okay, and number 10. It says point E is chosen at random on XY. Find the probability that E is on line AB, okay? So E is somewhere on this whole line, but we want to find the probability that it's on AB. Well, AB right here, AB makes up 3 of the whole thing. So to find the probability, we're going to say it's 3 out of, and the whole thing is 2 plus 3, it's 5 plus 4 is 9. So the probability of picking E between A and B is 3 out of 9, or if we reduce that would be 1 out of 3, which is 1/3, or you could write it as 0.33. Okay, 0.33. So any questions after going through all of these? Well, if not, remember your test goes live at noon today. You'll get the thing on Google Classroom probably before that, saying that it's, or just linking it on there, but it won't be able to open until noon. And it does close at 11:59 tomorrow night. Now, questions from other classes. One is, can we retake the test if we don't do good? The answer is yes, you can retake the test. You just have to email me and ask that you want to retake it, and then I'll send you a different link for it. But just, yeah, you can do that. So don't freak out. If you want to go over the test after you've gone through it, we're more than welcome to. If you want to go through any questions on the test before you retake it, that's cool with me. I'm totally fine with that. Anything else? Just remember, after Wednesday, the test is done. We're going to start a new chapter. The new chapter will be on similar material, very similar to what we did here. It'll just be a little bit longer, maybe a little bit more in-depth version of it. But it'll hopefully, you'll have some good background knowledge for it, okay? All right, well, if there's nothing else, have a good rest of your day, guys. Thanks for coming to class. You don't have anything else you have to worry about today unless you want to start on the test. And we'll talk to you later, okay? All right, have a good day, guys. We'll see you later.